Fluorite is arguably the most colorful mineral on Earth. In its pure form, it's colorless and transparent, but more commonly, various elemental impurities give it all the colors of the rainbow and even black. It's usually seen as octahedral or cubic crystals. However, when very small crystals grow outward from a central point, spherical botryoidal fluorite can be produced. Fluorite gets its name from the Latin fluo, meaning to flow. This is because the mineral was used during the Middle Ages to improve the workability of iron or other metals during the smelting process. Fluorite is still used today as a flux in the production of steel and other metals. In the fluorite molecule, one calcium atom ionically bonds with two fluorine atoms, forming calcium fluoride. Fluorite samples are colored if a few of the calcium atoms in the fluorite crystal are replaced by other elements from the periodic table. Many times these elements are the rare earth elements. Rare earth impurities can also be responsible for the well-known UV fluorescent properties of fluorite. My green fluorite samples fluoresce bright blue under long-wave UV light. Let's look at the science of what might be happening here. With white light, impurities such as samarium, dysprosium, and thulium may result in blue and red wavelengths being absorbed. As a result, only the green light is seen by the eye. With the UV light, it may be that electrons in europium atoms are excited to a quantum jump that produces photons of intense blue light. This cubic fluorite sample, which mostly shows blue-gray crystals in visible light, also glows intense blue with long-wave UV light. Note that the clear crystals at the top of the sample don't fluoresce. Fluorite is usually translucent. You can see the green light from this laser easily pass into the crystals. This black rose fluorite is one of my favorite samples. It's black because it's absorbing most of the visible light falling on it. It shows minimal translucence. The green laser light appears to penetrate the crystals by only a small amount before it's absorbed. With UV light, color changes are dramatic and varied, illustrating the different impurities within the crystal. The fluorescence of the black rose fluorite isn't as bright as the blue fluorescence seen with my other colored fluorite crystals, but the shift from the black to the reds and blues and purples seems almost magical. When I looked at all of my fluorite samples, long-wave ultraviolet light generated more dramatic fluorescence than the short-wave UV. Thanks for watching, and if you enjoyed this video, please like and consider subscribing.